Welcome to step 2 of basic physics in games. And first thing I'm going to do, just in case you're curious about how to save in Pico, you go save physics test. Now that I've set that, I can just hit Control S to save it from any location in Pico. Don't want to lose all this work we just did. Now, what we're going to do, we're going to add some collision. The man's falling down, the next thing he should do is hit something, otherwise it's a very short game. So, the first thing we need is some ground, so we'll just draw some ground. This is the level editor, not what we want just yet. We need the sprite editor. How about we make some bricks? Oh, this is going to be great. Awesome. These are going to be ugly as bricks. Oh my goodness. And they're going to be unevenly spaced. That's cool. Oh my goodness, these are going to be some really bad looking bricks. That's cool, I just drew them real quick. Now, full screen. Draw some bricks down there. Alright. That doesn't help us because he will fall straight through them. Nor can we see them because we haven't drawn the background yet. So because we're in Pico, I'll just have it draw the map in the behind the player, but not before the screen is filled with the big black square. Oh, by the way, here's what happens if you don't... oh, hang on a sec. Yes, I should say that I've dropped the resolution down to standard def 480. Perhaps that had to do with the frame rate drop, so we'll see. Either way, we're going to see what happens when we don't draw a big black square in the background first in Pico. Whoa! Cool. That is as basic as it gets. We even have to clear the screen for the computer. That's something you didn't know was happening every frame, did you? I think the frame rate's a bit better now. Maybe I'm just getting used to it. So after we clear the screen, we draw the map, and we draw how much of the map? Well, start from 0, 0 at the top corner. We draw it at screen position 0, 0, and we want to draw 16 blocks of it. That sounds right. There we go. Fall straight through. I'm going to give my bricks really quickly. Now, how you will make your ground solid in your game is different. Basically, you need a way to test collision. That's going to be different, but there is a way to do it, and whatever that way is, once you replace what I show you with that, it'll be the same. I'm going to set a flag on the object, and really quickly, I'm going to mget, which is basically the map get player position, but the player's in pixels, so we have to convert that to tiles by dividing by the size of the tile. There we are, divide by 8. Mget, we have what's at the player's position. If mget, I'll tell you what, I'll ignore the flag for now. We'll just assume that 2. We'll call 2 a brick. Excuse me, brick. I'll call it ground, because we're going to get rid of this real soon. We can't just have check for every type of tile and check if it's solid. We wanted to set a flag that means solid. We'll check for that flag, but that just complicates the code for now. I just want to check ground equals 2. Ground is tile 2. So if mget equals ground, then put the end in first so that we don't forget. If mget's ground, then here's what we'll do. Before we apply the velocity, at least the falling velocity to the player. We'll just check that I'll show you what happens. We'll just check if the current position, we'll just set the Y velocity to 0. Problem is, by this point we are inside the ground. We need to correct that, but we'll just at least dock. Oh, but he still tries to move, and then he keeps going. That doesn't work quite so well. What happens is every frame, it checks if every frame... Oh, the other thing is he is checking his exact position. We need to check one block below, which is going to be Y pos plus the size of him, which is 8, because all the tiles are 8 in Pico. Just save, run, at least and then he sinks like quicksand. That's not good, because all we're doing is setting the Y velocity to 0, but we've already applied it. So all this does is set it to 0, and then what happens next frame? We add gravity to velocity, and it adds it again, so it's going to constantly push him through. So what we should do is check before we apply the velocity that he's not already in the ground, and stop adding velocity if he is. The problem now is he's still moving. Yvel equals 0, Y positive, Yvel. Oh yes, we're still adding gravity. How about we add gravity first, check if it needs to be set to 0, and we intercept, we set it to 0 before it gets added. That's probably a good move. And douche. Right. Now you'll notice, okay, it seems like it's working, but he's 1 pixel inside the ground. You may be able to see that. And we need to correct this. Now this is where we're essentially making our own collision. If you've been following along so far, this is all there is involved in collision. The super high detail physics engines that you'll be using are a bit more involved than this, but this is the basic premise, and this is all yours needs to do if you're creating a simple arcade game that's not physics based. You know, if you're making something like with water physics or something that's very physics-based game with things bouncing around and weight and stuff, that's where you're going to want someone else's physics engine or the built-in physics engine in the game. But if you're just making an arcade game, you're shooting things, testing for collision, jumping on platforms, pushing blocks, you can just do riding on moving platforms, all that stuff. You should do your own physics because it won't take long, and it will work solid. You won't have any falling through the floor. And if you do, you know where to fix it. But look, sometimes you get glitches in complex physics system and you don't have much choice but to tweak them. But anyways, so now we need to correct this. If we're inside the ground, we need to back out. One other thing to do is to, well, first we'll just back out. We'll go Y pos minus equals Yvel. We'll back out of what we did and we'll set the velocity to 0. Now what happens? Okay, that's not good either. What's happening? Well, he backed out, but he backed out by the amount that he was moving in the last frame, which was actually quite a big jump by the time he reached the ground. He was moving half a pixel, 1 pixel, 2 pixels, 3 pixels, and then he was like, oh, I'm inside the ground, I'll move back 3 pixels, which might be, depending on when it happened, too far. You're not flush. So if you're working in tiles, this is very trivial. If you're not, you're going to have to do some kind of loop where you move down one pixel or one 3D element unit and check again until you find the ground and back out 1 and then you're there. But because we're working in tiles, it's even easier, and that's why all the old games worked in tiles, because you could do a lot of very simple math, very lightweight on the damn tiny little processors those things had to keep the cost down. And well, it gives us a certain charm that we have now. Everyone likes the retro aesthetic. So Y pos, we can cheat. Instead of backing out exactly, we'll just round down to the nearest 8 y pos equals, there's a little trick, minus equals y pos mod 8, which is basically subtract by whatever's the remainder if you divide by 8 as many times as you can. We'll see if that works. Oh, magic. Just magic. So it basically means if he's at a position like, say 64, 64 is equally divisible by 8. And just say he's at 65, 66, and he's 2 pixels through the tile, and he needs to be at 64, well, if you use the modulus symbol, it basically returns whatever the remainder would be after you've put in this figure as many times as you can. So 8 goes into 64 however many times. But if it was 65 or 66, we'd have 2 remainder. So we subtract whatever that was. And this is just a magic little line. If you feel like you need a bit, you want to know more about that, feel free to just Google it. But for now, it's magic. But it's very, very, very useful. You can do a lot of things like dates and things with that. So, right, well, and why does he stay on the ground? Well, basically, if I walk off the edge, he will fall. But you don't get to see it. Let's put a hole in the ground. There. So, gotta walk. Yeah. Okay. And why does that work? Because he's always trying to move down every frame. We have collision, and now we have gravity. Basically, every frame he tries to move down, if he's on the ground already, he finds out, he resets himself back, and nothing happens. Nothing gets moved. So, yeah, that's basically what's happening in every game. It's always checking to see if they're on the ground. And if they are, then they don't move. But if they aren't, they start falling. That's happening all the time for every object in your game, in every game you've ever played. It's not intensive, as long as the check isn't intensive. And in this case, it isn't. M gets very efficient. Now we're nearly out of time again. So now that we've got collision, I'll leave it there. And in the next step, we'll do friction, so that you get that sort of Mario-esque speed up and slow down when you move. You'll see what I mean. So, see you in step 3.